and then recycle it at the material level, which will result in the form being lost, and so it becomes something else, commonly known as upcycling or downcycling. You have other options as well, like repairing, and so you've got, there are some efficiency losses when you use a product for another phase, not necessarily a full life cycle, but you give it a little bit more usage and functional time. Refurbishing is another aspect of that circular economy modality where it involves more than repair. Sometimes parts are replaced and there's some cosmetic work that's also done. Remanufacturing is kind of the holy grail from the standpoint of product life cycle extension, because what it really does is it gives a product an entirely full new life cycle as compared to a new product. So in other words, at the end of a remanufacturing process, which I'll talk about in a second, a remanufactured product and a new product should be indistinguishable. You should not be able to tell the difference between a new product and a remanufactured product from a visual appearance perspective, from a quality and functionality perspective. And certainly when done properly, and the legitimate companies that are remanufacturing sell them with a full warranty. So let's look at the process real quick. Starting at the top of the diagram where it says original user, that's really where a company or an individual that's using a product has got now what's called a core, which is an end-of-life product. So it's no longer doing what it's supposed to be doing, or not doing it in a way that it was originally designed. And so from a process perspective, what you want to do is you bring that core back into the industrial environment, which requires collection and reverse logistics. So you've got to have the infrastructure in place to bring an old non-functional product non-destructively, carefully back into an industrial environment. It then involves disassembly, cleaning, and inspection, which can happen in several iterations depending on the complexity of the product. Once that's done, once it's sort of taken apart non-destructively, it's compared to the original specifications, and now you can really kind of tell which parts are worn, damaged, need to be replaced, rebuilt, or in some cases, depending on the product, which can be upgraded, and that sort of depends on product design, whether it was designed for non-destructive disassembly, whether it was designed for remanufacturability from the standpoint of upgrades and that kind of thing. Once that's done, it essentially follows the same process as a newly manufactured product, which is to say you go through the process of the reassembly, you go through the process of quality assurance and quality testing, and that can again have several iterations to it depending on the complexity of the product. And then it re-enters the supply chain, and that could be going back to the original user or being sold to a new user. From a definition perspective, and this is a definition that was agreed to by several industry associations from around the world, including the Association for Sustainable Manufacturing in the US, CLEPA, APRA, and a few others. So essentially, it's a standardized industrial process in which cores, and by cores we mean end-of-life products, are returned to a same as new or better than new condition from a performance and functionality perspective. It has to be in line with specific technical specifications, so it's not sort of a let's figure it out as we go along way. It has specificity to it. It has protocols associated with it. You're not sort of winging it as you're doing it, which includes the engineering quality testing standards, and it yields fully warranted products. And this is kind of the sort of test to see whether something truly qualifies as being remanufactured or not. And the diagram at the bottom kind of shows what it looks like from the standpoint of its position in the overall architecture of an economy, starting from the left where you talk about raw material extraction, the creation of materials, then components, then products, and then going to retailers and the end user. As you can see, the remanufactured loop is really from the product user to the component manufacturer, or going to the product manufacturer. And then there are other smaller loops where it could stay with the user through repair or refurbishing or redistribution and go to other users, or some kind of work to give it a little bit more life, but not necessarily all the way to the point of being remanufactured and giving it a full life. To be able to remanufacture a product, there's some criteria that need to be met. This is a list that was put together by Boston University a number of years ago, and certainly this is a very broad list, speaking in general terms, and so obviously depending on the product, the criteria are going to vary, but broadly speaking, the technology to remanufacture the product needs to have been developed. The product, by virtue of its design, is made up of standard interchangeable parts, which matters from the standpoint of that quality and functionality aspect. Costs make a huge difference, right? So it has to be cost effective from a business sustainability perspective, which is to say, if bringing a core, an end-of-life product back to the industrial environment becomes the sort of inordinately expensive part of the process, then it's likely that from a financial and business perspective, it's not going to be sustainable in the long term. So economies of scale certainly matter there, but also the design of the overall system, whether it's the nature of the reverse logistics system, the technology and transportation systems used, and the relative location of reverse logistics hubs compared to where cores are generated and where the industrial facility is. All of those factors come into the picture. Product technology certainly needs to be stable over multiple life cycles, and that can be challenging for some product categories, but for heavy duty machinery related operations, product technology tends to be stable for quite some time. And lastly, again, this is not an exhaustive list, but certainly there needs to be market demand. And this again goes back to that original point that was made at the beginning by Professor Chattopadhyay, which is if people don't know what remanufacturing is, and they don't understand that remanufacturing results in products that are as good as, or if not better than new, and that it has dramatic effects from a climate and environment and job creation perspective, which I'll come to in a second, then people are not going to ask for it. And I think this is an issue that is sort of universal in that the perception of remanufactured products is mixed. Often it gets lumped into the world of recycling and refurbishing. Sometimes, unfortunately, it also gets compared to secondhand products, but it's not the case at all. And this is something that I really want to kind of drive home, that it's not secondhand in the way we think of it. This is only then would companies provide a full warranty to these products. So which industries undertake remanufacturing? I was at a workshop a few months ago, and we had some participants from the pharmaceutical industry, and clearly pharmaceuticals can't be remanufactured. It's something that's consumed by and metabolized in the human body. So of course you can't remanufacture pharmaceuticals, but you can remanufacture pharmaceutical manufacturing machinery, right? So machinery, aerospace equipment, components in the aerospace industry, the automotive industry, which is sort of the birthplace of the remanufacturing industry, consumer products, electrical white goods, air conditioners, refrigerators, washing machines, all of those things that are used in sort of common usage at a day-to-day level by consumers, not just businesses, that have motors and pumps and bearings and that kind of thing. They're all fair game for remanufacturing, including computers and information technology equipment. And this is kind of a big issue that I think was briefly mentioned by one of the speakers at the inaugural session yesterday, the issue of e-waste. And again, it's design dependent, but to be able to design products where electronic circuit boards and equipment have the capacity to be utilized over multiple life cycles is going to be a huge piece of how the future of that industry is worked out and managed, especially from the standpoint of waste generation. So here's an example of going from the industry level to the product level, as I mentioned, things like machinery and motors. But this is again not an exhaustive list. The sky is the limit in terms of what can or cannot be remanufactured. I mean, obviously within specific industries, but a lot of it really depends on the product design, economies of scale, and the rate of product technology change. But if those factors are accounted for, which really means to make remanufacturing the mainstay of how we think about manufacturing, because this is the vision. The opportunity that's presented to a country like India is the creation of a manufacturing ecosystem where multiple product life cycles are the fundamental norm. This is the vision. This is the kind of ambition that I believe we need to be approaching, how we think about how products are fundamentally designed, produced, and then recirculated within the economy. It has tremendous impacts from the standpoint of not just environmental resource efficiency and conservation. It has dramatic impacts on climate from the standpoint of the greenhouse gas emissions over the product life cycle, as well as the capacity for job creation at the local level. So here's some of those benefits that I was briefly mentioning. Just looking at it from a greenhouse gas emissions perspective, which is a front and center issue. It has been for decades, but with the rate of the pace with which the crisis is now affecting countries, neighborhoods, communities, with increasing unprecedented temperature rises, the risk of water sea level rise. This is really, a big, important piece of how we think about shaping the industrial narrative going into the future. Not just 5, 10, 15 years, this kind of thinking needs to be in the 30, 40, 50, 100-year time frame if need to be. But from a greenhouse gas impact perspective, based on studies that have been done, and it's out there in the published literature, for example, it can decrease environmental impacts of key vehicle components and result in up to a 79, almost 80% global warming potential reduction. From a pricing perspective, remanufactured products are typically sold at 60 to 80% of the cost of a new product. And so think about that, right? One of the questions that often comes up is by shifting part of your production and manufacturing to remanufacturing, is there a danger or risk that you cannibalize your own product categories or your own market? And the short answer is usually no. There's the opportunity to enter new markets, but then also with a growing environmental consciousness, you're more likely to retain and grow your existing markets as well. From a job creation perspective, there was a study that was done by RAP in the UK and the Green Alliance, and they estimated that through reuse and remanufacturing, 8 to 20 jobs could be created per 1,000 tons of unwanted products, compared to 5 to 10 jobs for recycling and as little as 0.1 job per 1,000 tons of products sent to landfill. Right. So this is again, I want to be clear about drawing the distinction between recycling and remanufacturing. They mean different things, and often they tend to get lumped together as remanufacturing is just another kind of recycling, and they're really not the same thing. There's a much greater degree of sophistication, investment, technology utilization, and labor force activation that is involved in remanufacturing. As you might have guessed, there's a reduction in raw material usage, energy usage, waste production. If you remember the set of diagram that showed it in the context of the circular economy, when you have a product that has multiple life cycles, you're essentially not producing something from scratch, which means that you're eliminating the need for raw material extraction. There's a conservation element associated with that, as well as the carbon emissions associated, the energy that goes into the refining and the intermediate production of materials and components. So there's a significant impact from that perspective as well. In terms of customer relationships and purchasing flexibility, I can give you an example that really sort of came about as a result of COVID over the last couple of years, where when global supply chains were impacted quite significantly, and I have colleagues who are in the space of remanufacturing that work in commercial remanufacturing operations. Many of them were approached by their customers essentially saying, we're stuck and we need to figure out whether other products that we had not originally considered to be remanufacturing worthy, can you help us reverse engineer some of this and see whether we can remanufacture other products which we hadn't considered before because the supply chain is bottlenecked at the moment. So there's this real sort of nexus that comes into the picture from the standpoint of really kind of sparking the innovation ecosystem, rethinking design, thinking about it in terms of localization and what that might mean from economic development perspective, job creation perspective, etc. So that's again, as I mentioned at the beginning, and also to be mindful of time, I'm painting in some very, very broad brushstrokes, but I wanted to kind of leave you with a clear sense of what remanufacturing is and to really kind of see it as its own thing, and not to be confused with any of the other circular economy modalities, which have their place, but remanufacturing has been around for decades now. There are even ISO standards associated with it, so it is quite well developed in various industries. From the standpoint of its relationship to sustainability, I thought it might be worthwhile to look at sustainability, zoom out a little bit and look at it from a broad framework perspective. And I know that there's, frameworks like the triple bottom line framework, which talks about the economy, the environment, and society as a Venn diagram, and the center point of that is sustainability. My preference is what's called the 5 capitals model from a framework perspective, which is the nested model of sustainability, which says the environment is the outermost circle, society is the smaller, the blue colored circle nested within it, which includes social capital and human capital, and then the gray circle, which is the economy, is much smaller within that. And I think this is, while simplistic, is an appropriate representation of how the world and the economy works. The economy doesn't produce the environment. The environment is the foundation on which the economy is built. So when we are less careful about the impacts of economic activity on the environment, what we end up doing is that we are essentially eroding the foundation on which the economy is fundamentally built. And the next diagram really kind of drives this point home from the standpoint of, at the center of it, you've got 3 primary actors: business, finance, and government. And this is from a report that was published by the Cambridge Institute for Sustainability Leadership called Rewiring the Economy. And the metaphor or analogy is that from the standpoint of the economy being in motion, business is the engine, government sets the course, and finance provides the fuel, right? And that's what moves the economy forward and then produces goods and services that are in service to society, that provide public value from the standpoint of the work that the economy does. Draws on ecosystem services from the environment, utilizes natural resources. And then, of course, the waste and emissions aspect, which is really kind of the problem and the danger that the activity of the economy is seeping back into the environment, which it has been for some time. And climate change is kind of that the issue that we face at the moment. But understanding, when we talk about sustainability, understanding it from the standpoint of this nested models perspective is dramatically more important as opposed to the triple bottom line perspective. When we talk about sustainability, often I think it's just sort of looked at simply from the perspective of environmental issues. If you're familiar with the Sustainable Development Goals, the 17 goals that were agreed to in 2015, which are to be aimed at by 2030, I pulled out 5 of the goals which are broadly the work that remanufacturing does impacts. Starting at the top, goal 8, which is decent work and economic growth, which is part of why we're here today, talking about remanufacturing and its opportunity for what it can do for the economy. I'm intentionally not using the word growth too much, primarily also because when we talk about the circular economy, we're actually trying to decouple resource utilization and growth, right? In a linear economy, that growth has been in tandem. And so for the economy to grow, resource utilization has continued to grow, but that's just not sustainable as we're seeing. And so in a circular economy, you want to decouple those pieces, but also to not simply think of growth as growth for the sake of growth as a proxy indicator of development. That myth has been debunked, and to simply think of GDP as being the primary thing that we should be concerned with from the standpoint of social development, for example, is simply not true. We need to be specific in terms of what outcomes we want. The economics matter, but simply fixating on economic growth, there's a real danger, because economic activity could be digging holes in the ground and filling them in the ground back again, and that doesn't do anything productive, but it would add to GDP. So we need to be careful about which metrics we're looking at, and look at a broader range of metrics. And I'll come to that a little bit later from the standpoint of the roles that we have to play as stakeholders, and which metrics need to be looked at, and why even the identification of metrics needs to be looked at carefully. Goal 9, which is industry, innovation, and infrastructure. Often goal 12, which is responsible consumption and production, is the most closely linked to remanufacturing. Certainly goal 13 in climate action, and then partnerships for the goals, which is essentially what we're here today doing, is to, again, kudos to NIMT and the forum for putting this platform together so that we get to hear from each other. There's an opportunity for cross-pollination, and to see what new pathways, both from the standpoint of applied research, education, curriculum development, investment, and industry action that can emerge, which are all things that need to happen, and all the things that Recreate is also interested in. From the standpoint of stakeholders, my preference, and this is the way we think about it at Recreate, is to look at stakeholders from a much wider lens. And so to look at it not just from the standpoint of the private sector and the government and finance, which in the Cambridge report are highlighted as kind of the dominant actors, but to zoom out and look at it from the standpoint of the role of academia, which is again a huge piece of this. Chambers of commerce, competitors, the general public, essentially civil society, NGOs, regulators, which is part of the government. So look, kind of zoom out and say, okay, what do all of these, what roles do all of these stakeholders have to play, and what's the best way to go about engaging with them? And stakeholder mapping and prioritization as an activity, ecosystem mapping, these are significantly important steps from the standpoint of the forward momentum and clear pathway that can be generated for the growth of this, or expansion of the modality of remanufacturing in India. There's a really good report that was published a couple of years ago by the International Resource Panel, which is from the UN, and the report's title, which is listed right at the bottom, the Redefining Value report, talking about the manufacturing revolution and remanufacturing, refurbishment, repair, and direct reuse in the circular economy. And all of these are called value retention processes. And so, as part of that report, at least from the standpoint of government and industry, what are the opportunities from the standpoint of establishing strategic priorities? From the government's perspective, I think this is, I think it's common in many countries where remanufacturing has grown over time. Some of the challenges can include things like market access to the finished products, whether they're being produced internally or coming in from outside the country. The recovery of the product. So when a product reaches the end of its life, it sort of falls in this gray area of whether it's categorized as a waste or whether it's categorized as a raw material. And I think things like that need to be kind of worked out so that companies that are interested in undertaking remanufacturing aren't up against rules or legislation that offer just too much of a black and white delineation and don't have room for thinking about end-of-life products as raw materials for new products. Market demand is ultimately we want these remanufactured products to be well designed and be adopted without hesitation within the marketplace. And that means that, working with a broad range of those stakeholders that I had outlined in the previous slide, how do we shift the narrative of how remanufacturing is perceived? That is going to be a big piece of whether or not remanufactured products are broadly accepted by the markets. By markets, I mean it can be it's us as consumers, it's other businesses that are transacting with products in the B2B space. From the standpoint of efficiency and optimization of production, which is at the bottom right of this little image. And some of this will be covered in the Industry 4.0 parts of this workshop series, but there's a huge and exciting piece there from the standpoint of this optimization of production systems, both from the standpoint of the utilization of technology, as well as the sort of streamlining of the reverse logistics, the movements of goods, and the relative location of where the industrial facility is, where the reverse logistics hubs are, and how to kind of integrate that in a way that brings end-of-life products back, and then remanufactured products back to the market with efficiency, with speed, with as low impact as possible, especially from a greenhouse gas emissions perspective. So I'm almost at the end of my time and end of my slides. I want to leave you with just a few final thoughts. Going back to the Rewiring the Economy report, there are some great suggestions from the standpoint of what the various, at least the primary actors as outlined by the report, can do: the government, the finance industry, and business. And really, we need each other. This is a team sport. We're not going to be able to get there by ourselves. Certainly, competition is good, and companies should and be encouraged to compete to produce the best products. But we need to kind of think about what we mean by best products and best services, and to integrate responsible stewardship of natural resources, what it means from the standpoint of the negative impacts and harmful impacts of waste generation and the people affected by it, as well as the creation of jobs and the development of an economy that are skilled, high-paying, and result in outcomes that don't hamper the future from the standpoint of environmental implications. That's a systems thinking problem ultimately, and so we have work to do to work together. For example, just the first bullet of measuring the right things, as I mentioned before. And I think that's a critical piece of how we structure the economy, and what outcomes we're actually shooting for. Because if you're measuring the wrong things, you're going to keep working towards an outcome based on a metric that is inappropriate. From businesses, bullet 9, embedding sustainability in practices and decisions. This is the business as usual scenario really will not get us there. And so to take a step back and think about not just the products we're producing, but to think about it in terms of the systems that we operate within. And that can result in insights that shift us from thinking about production from a product-centric perspective to a service-centric perspective. And there are many examples of companies that have shifted towards providing products as services, the PaaS model, as opposed to simply the selling of the product. And in that service-based or subscription-based model, access to end-of-life products becomes dramatically easier, because those products still technically legally belong to the company. And so in a subscription-based model, the utilization of technology to keep track of the efficiency, quality, state of play of the product, as well as where it's located and how to then bring it back for things like remanufacturing, can be dramatically helpful. I'll leave you just with a couple of thoughts on Recreate. as Professor Khandelwal mentioned at the beginning, it's India's first and only research and advocacy think tank that specifically focuses on catalyzing and advancing the remanufacturing industry. It's a relatively young organization, but we've been very blessed to have been offered a seat at the table with colleagues and counterparts, both in India as well as in Europe and North America. And we're excited about what the prospects are in a variety of spaces, from the applied research and development space to the development of educational curriculum, not just at the university level, but also training programs for companies. Workforce development is a huge part of this, and on-the-job training is significant. And the development of policy. I think this is going to be a very important touchstone and critical from the standpoint of the narrative and the direction the industry takes. India has a national manufacturing policy. Could it be possible that by virtue of the conversations we're having at today's workshop, that we think about a national remanufacturing policy and what that might look like, and the role the government can play from the standpoint of things like sustainable public procurement, where the government itself is a purchaser of remanufactured products, and that can result in lowering the risk for companies that want to enter it, as being the first buyer, and therefore de-risking it for companies that might be lukewarm to the idea at the moment, but with the right incentives in place, whether it's purchasing related or taxes. That it creates a fertile environment. And that's really ultimately what we at Recreate are interested in. We're interested in working with an entire cross-section of collaborators, developing partnerships, and creating the conditions in the environment where remanufacturing, as it is today, and a nearly sort of unknown concept, broadly speaking, in India, becomes the primary way of how we think about manufacturing. So that's all I have. I'm happy to take any questions. I know we just have a few more minutes left, but thank you again to the National Institute of Advanced Manufacturing Technology and the Futuristic and Advanced Manufacturing Forum of India for the invitation to come and speak to you. I hope that this conversation has been helpful. My intention was always to paint a big picture overview from the standpoint of setting the stage for what's discussed for the rest of the workshop series. So congratulations again in taking a leadership role in bringing this forward, and for your kind invitation for to have me speak here today. So I will stop sharing my screen, and if there are any questions that have come in, or if any of the other panelists would like to ask anything, I'm more than happy to answer.
Yeah. Thank you, sir, for sharing your views on this bit. So, we have one questions. The participants can actually ask the questions in the question answer section, and they can also post in the chat section. And participant can also raise the hand if someone will raise. I can, we can allow them to, ask the question personally with, Ramchandran sir. So, sir, there is one question. This is from Mr. Rajnikant Chandan. He is asking, sir, please put some light on remanufacturing and recycling. So, I believe already you have talked all about that. So, would you like to answer this question, sir? Sir, your microphone is, I think, off.
Thank you. Yeah, with very briefly. So recycling is often the word recycling is used, and we're talking about material recovery. So it's down to say plastics, for example, or even steel and aluminum. And so you get to a point where the product in its particular current form is no longer usable. And so what you're then interested is taking, you're thinking about it at the substance level. And so then you're, in the case of steel and aluminum, you're melting it back down and you're forming it into a different product. You can do the same with plastics, but with plastics, there are several options, including things like depolymerization and then going back to the monomers and then polymerization again. So that's kind of the fundamental difference, is that recycling is at the material level. In remanufacturing, the product in its forms, the integrity of the product is maintained. So an engine, when it goes through a process of remanufacturing, or an electric vehicle battery, when it goes through a process of remanufacturing, is still the same product. It still is an electric vehicle battery, but by virtue of disassembly, cleaning, inspection, repair, replacing, upgrading, and then reassembling it back together, you're giving it a full new life cycle. And I think that's the critical difference, is that the utility of the product by virtue of the form of the product is maintained. With recycling, you're at the materials level, and so it could become anything else. It could be upcycled or downcycled.
So there are a couple of more questions. I think you can also see in the question answer section.
Yeah.
You can pick which one with you. You can you like to answer.
Yes. No.
now.
These are no.
We have time limitations also.
Of course. Yeah. I'm noticing the time, and actually, what's nice to see is that there are questions coming in, right? Because that means that maybe they were paying attention, or maybe I did a terrible job and they didn't understand a word of what I said. I don't know, but in any case, let me. I'll pick one more, and I'm happy to have the participants reach out to me or work with you offline to address some of the questions at a later time. There's a question on the difference between refurbishing and remanufacturing. So refurbishing and remanufacturing are much closer. They're much closer together compared to recycling and remanufacturing. Sometimes they're used interchangeably, but usually refurbishing isn't as comprehensive as remanufacturing. In refurbishing, it's often thought about as there some degree of cosmetic upgrades, and then particular parts or components may be changed, replaced, or repaired. Versus in remanufacturing, the entire product is disassembled down to the last nut and bolt. Everything is compared to original specifications and then put back together. So refurbishing tends to address that which is already known as having failed in the particular product, as opposed to doing a comprehensive evaluation of every subcomponent, which may be close to failing but may not have failed, and therefore you wouldn't know until you've taken it apart. From a cost models perspective, there's no short answer. It just depends on the type of product. It depends on the costs of reverse logistics and the cost associated with disassembly, the degree of technology utilization. So that's a much longer conversation, and honestly, there's no kind of universal way of explaining. So let me stop there. I want to be mindful of not eating into the time of the other speakers. But thank you again for the invitation, and I'm happy to field some of these questions offline.
Yeah, thank you, sir. I like to present a small vote of thanks for you. So it's our really, a pleasure to present the vote of thanks on behalf of our esteemed organization, Institute. I would like to express our gratitude to sir for sparing his time for us and gracing this occasion with his vital appearance. Sir has given us a lot of information about remanufacturing background, the industrial standard, which can be pursued, and also it is really good to know about how Recreate is contributing in this field. And this is the only organization I can say from India which is contributing in a systematic way right now in this field. So I'm sure this may have triggered a new domain for all the participants and the faculties or researcher who has joined today. So I see there are right now 112 participants. So it's good. So once again, thank you, sir. Now I'll just share these questions to you also. If you would like to answer anything, we'll share this with the participant, because I see there are many questions right now. Okay, sir. Thank you. So thank you, sir.
Yeah, and I'll stay on, and I'll try to type some of the answers in the Q&A right now.
That will be great, sir. That will be
great. Very good.
Thank you.
Thank you so much.
Yeah, thank you. So yeah. So now it's time for us to invite our second speaker. We have with us Dr. Gautam Goswami. He's a scientist F, foresight studies and training technology with vision. He's from TIFAC basically. So welcome, sir. Welcome. So I'll just I welcome you on behalf of our both the organization. This is actually this program is organized by both NIAMT and this Advanced and Futuristic Manufacturing Forum of India. And so we are the executive committee member there. So on behalf of that, we invite you. So, sir, I'll just give a brief introduction about sir before starting. So, sir, actually, Dr. Gautam Goswami is presently scientist here in Taipei, New Delhi. Sir has done his PhD in agriculture, chemistry, and soil sciences in the year 1997 from University of Calcutta. So, in his PhD, he studies basically he developed a methodology of dissolution of iron oxide from soil matrix, which has been accepted internationally. So during his research career in the field of soil chemistry, he has availed the senior research fellowship from ICAR, then CSIR, and a research associate fellowship of CSIR. Dr. Goswami served 3 years in the University of Calcutta also in the capacity of guest lecturer for postgraduate student. Sir has also got training on the remote sensing from ISRO Institute. ISRO Institute in the field of National Natural Resource Management System and inventory and management of soil resources. Dr. Goswami has written, several publications and book chapters. One of the book chapter is like resolutions of iron oxide by carbonate oxalate method in the book. And Dr. Goswami has joined TIFAC as scientist C in the 1997. Sir is right now, scientist F there, and he has looked after the fly ash utilization project in the field of agriculture. Presently, he is coordinating the Technology Vision 2020 project on agriculture in TIFAC. So it's our proud privilege to have him today as a speaker of this session on the session on the remanufacturing for sustainability. And sir is going to give a talk on remanufacturing and approach towards sustainability. Now, with this word, I over this session to sir. Welcome, sir.
A very good morning, and I really am I audible?
Yes, sir, you are audible, sir.
I really thank NIAMT, especially Dr. P.P. Chattopadhyay, and the forum, FAMFI, for giving this opportunity to share my thoughts on the subject, which is very new to me. Actually, recently I visited your institute, and we had a 2 days interaction with Dr. Chattopadhyay, and that prompted me to join this conference. Now, let me correct 2-3 information which you mentioned, because you have read my very old biodata. I mean, yeah. Now I'm scientist G, and I am now I head the Technology Vision 2035 document, which our Honorable Prime Minister released in 1996. 2016. Then I am into climate change technology needs assessment program of Government of India, and I conducted several sessions in conference of parties. Anyway, that is the, but now let me share my screen and start today's discussion. Let's see. Is it visible?
Yes, sir, it's visible.
Okay. So, so what is my topic is restructuring for sustainable, just a minute. Restructuring for sustainability. The tagline which I choose is think circular to prepare the future. Let me confess that this topic is very new to me. Recently, I came across about in this area through Dr. Chattopadhyay, because we had a discussion about this issue, a couple of times, and then we thought that TIFAC, being a technology foresight organization, there should venture in and try to find out the possibility, explore the possibility in Indian context, because internationally this subject is very well known, remanufacturing, but in India it is still in a nascent stage. So before going into the topic, let me introduce my organization. It is a technology think tank under Department of Science and Technology. It was established in 1988 when our Rajiv Gandhi was Prime Minister of India. He wanted to form a similar technology think tank which is there in US, which thinks about future technologies for the country. And also it keeps an eye on the technology trends and also flags and alerts for government on emerging technologies, R&D pointers. That's the objective with which TIFAC was born. And TIFAC is governed by a governing council of eminent experts, R&D institutions, academia, and industry. In terms of activity, TIFAC has diverse type of activity. One is technology information. As the name, TIFAC names says so, technology information, technology foresight, technology assessment, and innovation support. So in terms of technology information, we prepare different reports, techno market survey report, then technology database preparation, technology expert network database preparation, also patent information. In terms of technology foresight, we prepare technology vision 2020 when Dr. Kalam was our chairman, and I was fortunate enough to work with him very closely, Dr. Kalam. Then Technology Vision 2035, which I headed, and in 2016 it was released by Honorable Prime Minister. Subsequently, we released technology roadmap for 7 sectors, then technology gap analysis for MSMEs, then demand-driven specialized reports, for example, food processing, biomass, solar PV, security technologies, etc. In terms of technology assessment, actually this assessment part came when Dr. Kalam wrote the idea that in an organization like TIFAC, when you talk about technology foresight, unless you assess on the ground, people may not listen to you. So technology assessment part came from that. So several technologies which were identified in Technology Vision 2020 document were demonstrated at field. And from that, several programs, Government of India chalked out, then technology needs assessment study for climate change, then technology assessment for funding, technology readiness level assessment for funding. These are all the part of the TIFAC activity. And TIFAC has a strong innovation support program. It supports innovation from in a 360 degree. It supports innovation even for individual innovator to a organization which can innovate. So it supports towards commercialization. So this is in a brief about TIFAC. Now, in terms of manufacturing, before entering into remanufacturing, let us understand what manufacturing is. Manufacturing process is. Manufacturing of a product is made from new materials and then follow a typical linear economy model. This is a typical manufacturing process is. What finally comes in, finally a product once made gets consumed and it ends up with waste generation and gets discarded. That is a typical conventional manufacturing system. But in this course, some parts of the product or materials get recycled and is returned back to the early stages of manufacturing, leads to loss of energy, emitted energy. From this, the remanufacturing concept were emerged. It leads to circular economy because every component which are getting discarded are being again reused with refurbishing and polishing and repairing, and which acts as a original component like this. Then second thing is remanufacturing promotes phasing out of waste, absolutely no waste. All products or byproducts or waste products are converted into value-added products and reused again. So it brings back end-of-life components to the economy. Let me give an example of solar cell. We are talking about solar energy, but if you see the solar panel life, maybe 8 to 10 years. So what will happen to that after 8 to 10 years? So people have started working on that. So that silica has to be extracted and reused. That is a concept people are working on. Then what is the benefit of remanufacturing? It saves financial and energy resources, leading to resource use optimization. So basically, conventional manufacturing clubbed with remanufacturing is the new mantra of manufacturing process. But if you see the definition of manufacturing, or you can say the concept of remanufacturing is a couple of things I tried to jot down. Steps required to change the product into as new with at least equivalent performance and warranty of new. Whatever the product are being produced as an end product, you need to work on it and then again bring it back so that it is as good as new. Remanufacturing is an industrial process by which a previously sold, old, or non-functional product or components are returned to a like new or better than new condition. Remanufacturing exhibits an affinity to the concepts of sustainable production and sustainable society. Of course, it is sustainable unless if we can use all the end product again back to use. The sustainability component, of course, automatically comes in, and society needs such type of sustainable propositions. What are the essential features of remanufacturing? To bring a used product to its original performance, dismantling a product, resorting, replacing components, testing individual parts or whole product. Then remanufactured product can be considered as the same as a new product. Performance after remanufacture is expected to be at least equal to original performance specification. That's why remanufacturing is all talking about. If you see the advantage of remanufacturing, it has potential to save energy up to 60%. It has potential to save materials up to 70%. It has water saving potential up to 90%. It has emission reduction potential about 80%. Overall cost reduction is around 50 to 70% of the whole manufacturing process. Then global warming potential index is 67% lower. Really important in terms of climate change perspective. Our previous speaker also flagged this issue because climate change is the issue is talked about, and our government is very committed to address these climate change issues and made several stringent commitments Honorable Prime Minister has made in COP26, and TIFAC is working on decarbonization roadmap of different sectors to match with the commitment made by Honorable Prime Minister Narendra Modi ji. And secondly, remanufactured parts are superior in terms of cost perspective, because when all end products are reused, of course, it becomes cost efficient. So in that context, remanufacturing has a lot of advantages. Now let us see where India stands today in terms of remanufacturing vis-a-vis global status. If you see the global remanufacturing component market is supposed to grow at a CAGR rate of 3.5%. Market size to reach about $5 billion US dollar by 2027 in compared to 2019, which was $3.8 billion. Key manufacturers, several key manufacturers, I have noted down few: Caterpillar, Komatsu, Hitachi Construction Machinery, Epiroc, and many more are there. In China, it has already prepared a Made in China 2025 plan, which promotes sustainable and healthy development of manufacturing industry. In Asia, East Asia, Japan exports one-third of its remanufactured product and earn high profits. If we compare India in this context, we are in a very nascent stage or initial stage. Though native in implementation and adoption, Government of India considered remanufacturing as one of the priority list. So this is very important. Government of India has given a lot of thought to this. Niti Aayog prepared a report which recommended for establishment of an industry body to promote remanufacturing industry in India. So these are the two things which Government of India has already taken note of it. MOFCC recognizes remanufacturing as the path to drive resource efficiency, creation of new jobs across skill categories. Taking clue from this, TIFAC and NIAMT has already started working on this to prepare an in-depth study on the techno-economic feasibility analysis study for a study for remanufacturing capability of India in select sectors. So we are in the stage of forming a proposal, and probably we will float this study and try to establish couple of units where demonstration units where remanufacturing technologies can be demonstrated. This is in short about India's position in remanufacturing status. Now, why remanufacturing in India? Partly I have talked about in the beginning. It gives environmental sustainability. It enhances economy because remanufacturing a product also, it gives life of the product. And for both important component is waste handling, because remanufacturing leads to very less waste, which is required from both climate change perspective and as also economy perspective. Where the areas where remanufacturing can be applied: heavy machinery and vehicles in mining and construction sector, automotive sector, electronics and healthcare sector, and many other promising areas where remanufacturing can be applied. There are several constraints. One is a technical barrier, because a single recipe won't work for all these areas. It depends on what are the areas, what are the components you're talking about remanufacturing. So we need specific technologies. Still a gray area in that. And another important component, lack of unified standards of manufactured products. Standards are missing. Previous speaker also flagged this issue. So this has to be taken into consideration for India when going for all along a new remanufacturing strategy. If you see the performance analysis of a product over time, if you see that if a green line is basically initial performance level of any product when it is launched in the market, but gradually loses performance if it is unprotected. If materials are unprotected, its performance declines. So red lines is the critical performance level below which it can be declared as a failure. If you use protected material, is time of failure or time of reaching to critical level is more. But if you, along with protected material, if you add some restoration mechanism, then it's use some restored material, maybe remanufacturing of replacement of old or damaged material, damaged components with remanufactured components, is life gets increased. So in a way, remanufacturing has a bigger role to play over here. Now I have taken 2-3 sectors to give an example how remanufacture helps in the industry. In automotive sector, there are a couple of examples where remanufacturing has helped companies to grow, to make their company grow. British listed Peter company can remanufacture 3,000 disused engines every year. Volkswagen in 2013 remanufacturing program they 983 million kilowatt hour of energy, about 350,000 tons of steel were saved only by remanufacturing of engines. BMW, their reuse rate is about 60%. Daimler, the reconditioning of a single remanufactured G28 281 track transmission saved 445 kilogram of carbon dioxide and 7,300 megajoules of energy compared with production of a new unit. These are the encouraging result for remanufacturing. What are the in automotive sector, the parts which are typically need regular replacement within the lifetime of a vehicle and known to people. Still, I have jot down some parts: brake parts, tires, clutch parts, windscreen wipers, bulbs, filters, chains, belts, like this. Many components are replaced periodically. So remanufacturing has a great role in this. If you see the heavy duty machine in terms of mining and construction machineries equipments, these are the equipments are exposed to harsh environments. So they are the damage factors of different parts, physical phenomena, chemical reactions, and biological impact. In physical phenomena, heat, force, radioactivity, etc. are the factors which damages the product. Then chemical reaction in terms of corrosion, in terms of physiochemical reaction, and in biological impact in terms of biophysical, biochemical, and interaction between life forms and engineering materials. These are the factors which damage these equipments. So remanufacturing has a potential to reduce those. So remanufacturing process of heavy duty materials and machineries is a complicated system which includes a series of processes such as delivering, cleaning, testing, disassembly, repairing, etc. Malfunctions or failures in these machines take considerable time to restore. So therefore, remanufactured parts provide a way to solve these issues. That's why this is very important in this sector application of remanufacturing technologies. So if you see in a broader sense, the lifespan of the machines is getting longer, say 40,000 hours to even 80,000 hours in the future. And to make this happen, remanufacturing has the potential to maintain the sustainability. In short, a machine's life can be extended without compromising on quality and cost, because through remanufacturing, you can regenerate the old one into new component, a new component of the industry. Owners will not only benefit from less machine downtime, but also a reduction in total cost of ownership by using higher quality components provided by a comprehensive warranty. So these are the small intervention from for the heavy industry in terms of remanufacturing technology. In terms of electronics, biggest challenge is e-waste management. So what is the solution is how to reuse the e-waste, reuse of device, reuse of components, shredding of materials recovery, incineration with energy recovery of product, dumping of into landfill. These are the basic solutions. However, there are a couple of methods, couple of techniques through which materials can be recovered from e-waste. First is repair, that is original product used after fixing or replacing the broken or faulty parts, which is normally done in any engineering product. Then refurbishing. Refurbishing basically original product quality restored after disassembly to a certain level, and repairing or replacing the faulty or broken components or parts. Remanufacturing has a bigger role over here. Basically, new product is manufactured from old product, recovered from disassembly of old devices, and new components. Technological upgrading may also be carried out through remanufacturing. like this, cannibalization, recycling, energy recovery, these are all technique can be used to recover material from e-waste. Now, in a short, what are the technology perspective for remanufacturing? What are the remanufacturing processes or activities? First is identification of types of damaged components. The non-destructive technologies can be used for this. Identification of nature and intensity of damage. Again, non-destructive technologies can be adopted over here. Elimination of damage. Once damage are identified, the damage can be eliminated through advanced machining techniques. Determination of dimension, geometry, and integrity through surface engineering methods. These are the remanufacturing processes or activities. But if you see the in terms of non-destructive methods, there are a couple of techniques are used: liquid penetrant testing, electromagnetic testing, X-ray computed tomography, infrared and thermal testing, ultrasound method. These are the methods which are used in non-destructive non-destructive testing methods. In terms of advanced machining, automated adaptive machining techniques are used. Three-dimensional scanning methods such as laser triangulation, structured light, time of flight laser scanner, then computer-aided manufacturing software being used in advanced machining technologies. In surface engineering technologies, automated nano-electric electro brush plating technology, automated high velocity arc spraying technology, semi-automatic microplasma arc welding technology, automated laser cladding technology, overlay welding technology, plasma transferred arc technology, thermal spraying for coating metal and non-metal coating applications. I have just jotted down the technologies. I am not detailing about each and every one because I know that the participants are quite well aware of. So these are the technology perspective. And thank you very much for giving this opportunity. I wanted to give a broad view of this new area. And I'm sure that TIFAC and NIAMT will work together to take it forward so that implementation or demonstration of some of the technologies are done in India so that it is a starting point for India to invest in this area. Thank you very much. Thanks a lot.
Thank you, sir. Thank you, sir, for your sharing your experience in this manufacturing. Sir, like there are few questions we'll take before moving to the word of thing. Sir, like you can you see questions, sir, on your list?
No, I'm not seeing.
I'll just read out for you, sir. So there is one question, like up to what extent e-waste can be remanufactured or recycled?
Okay. And next question is up to what extent? Same, I think.
Yeah, same
question. Yeah, actually, it all depends on the waste. Very difficult to give a concrete figure. It all depends. But as of now, many products are not recoverable. There are several techniques. Even we prepare a e-waste management report that also said that at least 50 to 60% can be recycled. But several reports give several figure. But to some extent, 50 to 60% recovery could be a sustainable proposition.
So, sir, there are two attendees has raised the hand. So I'll just them to. So this is Mr. Ankit Kumar. So Mr. Ankit Kumar, if you want to ask any questions, you can ask now. Then you are allowed to speak. Ankit Kumar. Yeah. So there is one more participant, Mr. Shomik Datta. Shomik Datta, Mr. Shomik Datta. Okay, so I think unknowingly they raised their hands. Yeah. So, okay, sir. So it's thank you, sir. Thank you for explaining in detail about the cycle of remanufacturing. Which can attain the sustainability in a long-term manner. And also you have explained really well to all of us, how the remanufacturing can address the climate change issue, which is very well needed, like the earlier speaker has also told. And it is very true that our India is at a very beginning stage of remanufacturing as compared to the global status, if we see. And the technology part, which you have actually explained, which is required to pursue this field, I'm sure this will be very helpful for the participants to to decide, like, if the researchers and faculty, how they can take this forward. So with this actually, sir, I would like to extend our word of thanks on behalf of our institute. Sir, thank you very much for sparing your time and sharing this lecture with us. And we really look forward to pursue this field and the collaboration which we are looking with the TIFAC. Thank you, sir.
Thank you very much. Thank you very much.
Yeah. So, sir, there is two more questions, I think, right now. Couple of questions, if you like to take. I don't know. This is a time.
Remanufacturing can only be economical if done by OEM, as other small players won't be. Yeah, I agree 100%. No debate on that. I agree with this. And second, how is remanufacturing can enhance our current financial as well as our production management for common person. So actually, remanufacturing is for the industry, and when remanufacturing is adopted in an industry, automatically cost-effective product can come out. So that will help a common person in terms of economy-wise, as well as in terms of industry, they can have a more life of a product through adoption of remanufacturing technologies.
Thank you, sir. I believe this participants they are okay, like whatever night they have asked. So with this remark, sir, I would like to end your session, sir, with your permission. So I like to pursue further. Okay, sir. So thank you, sir.
Thank you very much.
Yes.
I will sign off because I have some other program. So,
okay, no problem, sir.
Right. Thank you very much.
Okay. Thank you, sir. So now I'll welcome our third speaker, today's third speaker of the session of remanufacturing for sustainability. We have with us Dr. Goswami, Anshuman Hajarika, Dr. Anshuman Hajarika. Welcome, sir. I extend heartily welcome on behalf of our organization, our institute, NIMT, and this FAMFI organization. So it's my indeed pleasure and privilege to introduce you, sir, as a noted eminent faculty for this session. Sir is the faculty at IIM Ranchi, and I'll just give a brief introduction about you, sir, before moving to the session. So yeah, so Dr. Anshuman has completed BA LLB honors, and he has with a specialization of international law from RGNUL Punjab. There is also LLM, foreign trade and investment and international dispute resolution from European Institute of Saarland University. And sir has done his doctorate, Doctor of Law from again Saarland University, Germany. His research has been focused mainly on international trade and investment law and business ethics. And Dr. Anshuman has authored many journal papers and the blog article. He has been awarded the European Prize of Villa Leasing 2017, awarded for his master thesis by Villa Leasing Liberal Foundation, sir. And he has also got like Jawaharlal Nehru Award for International Understanding, Dr. Angela Merkel Scholarship by DART for master's studies, again from this European Institute of Basal and University, and International Climate Champion Program, Meritorious Contribution Award from the British Council 2012. So apart from this, sir has like national and international teaching experience. He was the research associate at the chair of Professor Dr. Mark Benjamin, Saarland University from yeah 17 to 20. He has worked primarily in the area of international trade law and international investment law. So, and it's a proud privilege to have him, sir, today in this session. And sir is going to deliver his lecture on remanufacturing the international business law and standard perspective, which is very well needed for this current session. Thank you, sir. With this, over to you, sir.
Water, no?
Thank you, sir. Good morning, respected dignitaries, respected speakers of the event, the organizers, NIMT, Ranchi, and FAMFI, and also my special thanks to all the attendees and all the faculty members and all the participants who have joined here. I would like to first express my gratitude to the director of NIMT Ranchi, who has provided me this kind of privilege and also the forum to speak on a topic which is generally not discussed. The closest that I have discussed in an academic forum on this topic was during my master's studies, when we had a subject which was called International Raw Materials Law. Now, the subject sounds very interesting. A key part of that entire process was how is the international trade in raw materials regulated. Now, this of course involves the process of control of export of raw materials from one country to another, and also the fact that countries now adopt increasingly protectionist measures to ensure that they have better access to raw materials. And this is where remanufacturing comes into the picture. Why? Because having the ability to repair products and also to recreate them to the original standard means that there will be a greater protection of raw materials, and it will provide greater economic security to the country. But that is the larger picture. We would try to go through a step-by-step discussion here. I say because at the end of it, we would also have a question answer session where we'll talk about the issues, and I hope that we will have a good discussion on it. Now, this idea of understanding the legal aspects of remanufacturing is still something of a nascent stage, particularly in India, because we are still in the process of understanding how exactly law would work here, what doctrines would work. Is it permitted under the law, and to what extent is it permitted to get involved in remanufacturing, and who are the players who can get involved? So we have a lot of questions. We try to answer a few of them here, but yes, probably at the end of the presentation, at the end of the discussion also, we'll be leaving with a lot of open questions. Right. So the topic of the presentation and the discussion today is remanufacturing, the international business law and standards perspective. Now, if you ask me, I am in an out of place scenario here because I am a lawyer who is surrounded by a lot of engineers, and engineers are probably the best people who understand about standards, because standards is something which I think is behind every manufacturing process, behind every engineering process, and behind every device, behind every development. There is always a standard which is developed, no matter whatever be the industry. So we'll not look into the nuances of standards because I think they're much more qualified and better people to talk about that here. But what I'll be looking at is the broader legal perspective of someone who is in the remanufacturing industry, or someone who wants to get into the industry. What is the entire scenario here? What happens here? Right. So just to present you a brief outline of what we are going to talk about, this is to basically provide you an idea what we will do here. So we'll start off with understanding a few definitions of remanufacturing. Well, this section I think will not focus much on, because what we have already had our eminent speakers before me who have provided a better idea on it. We'll look at the different parts of the remanufacturing puzzle. I will not look into what the parts involve, but what I'll look into is the legal questions in the different parts. Then we'll look at the end of life responsibility and remanufacturing, where they fit into the picture, what are the guidelines in India, and the focus areas of remanufacturing, ultimately going forward to the Basel Convention, which deals with transboundary waste management and how remanufacturing may be related with waste management as well. Okay. To begin with, this was one of the posters which introduced me to the concept of remanufacturing. And it's a funny incident. I saw this a couple, let's say, I think around 5 years ago. I was sitting in a garage when I saw a poster like this, Now, as a layman who is not an engineer, this intrigued me a lot. Why? Because I saw that there is a possibility that old engines do not go to waste. Normally, our idea is that when there is an old car, when there's an old vehicle, and the lifetime of the vehicle is over, it basically goes to waste. But here, I saw something completely different. I saw a picture where there are engines which are being rebuilt, and which are being resold. Now, while I have put up the poster and advertising material by one company, it's not like this is the only company which is involved in that. Later, I did some research and I learned that this is a common industry practice. But to tell you the truth, I did not know that this was the exact terminology they use, and this is exactly referred to as remanufacturing per se. So yes, there was a confusion on the terminology, but I did understand that there is something like this which happens in the market, that old products do not go to the landfill or do not go and get destroyed, but ultimately they can also be recreated and used again. So this was a very revolutionary idea for me, a very good idea for me, for someone who is not an engineer. But yes, from a lawyer's perspective, I realized that this will have a lot of legal angles as well. And this is what I explored today, encouraged by the director of NIMT, who told me try to explore the area and understand how this goes forward from here. Right. So in the first presentation, we looked at the typical remanufacturing process of what happens. And I will not go into the process again, but I will try to look at what are the legal issues in the different steps in the remanufacturing process. So our honorable first speaker, he has already provided a good idea. He has provided the entire industry perspective to it. So probably that is the best idea that you can get. But what I look for here is where are the nuances. So the first step again in the remanufacturing process is collection of the products which have to be remanufactured. Now, while it might seem simple to collect products, but in reality, this is one of the toughest things to implement on ground. Why? Because it means that people have to give back the products at a designated location, or you will have to come up with a mechanism to collect the products from the people again. Now, this may not be very easy, particularly if you are selling low value products, because what is the incentive for people to basically give you back the old product so that they could be remanufactured. Now the legal aspects of it is that the government has tried to curb this heavily and have tried to basically encourage people to give back old products by two ways. First by encouragement on the side of the consumer, and second by imposing legal responsibilities on the side of the producer and seller. So for electronic products, what happens is now we have something called a end of life responsibility or extended producer responsibility, under which all the electronic products which are sold by a seller or produced by a manufacturer have to be taken back by the original manufacturer. So yes, while at one end it looks like a waste reduction measure, but on the other hand, it also means that there is an opportunity now to remanufacture these products again whenever possible. But there are number of ways to encourage this. Well, making it mandatory looks good. What will happen if people who are the buyers do not give you back the product? So different producers have different incentives to do that. Some producers, what they do is that when you return the old product, they give you a value in the form of a coupon, which can be used to buy a new product. Others, what they do is that they give you exchange value for the old product, so that you can return the old product and you can buy a new product immediately. So there are different ways by which producers have taken it, but ultimately it's a legal responsibility, particularly in India, the European Union, that producers have to take back electronics products that they have sold. The next is collection and transfer across borders. Now, shipping products across borders is not as simple as it looks, particularly if they are old products. There is the Basal Convention on transport of transboundary wastes, which governs how waste can be transferred across borders. So while yes, it might seem simple that you just collect the old products and get it remanufactured across the globe, but legally implementing that takes a lot of compliance. So that's the first step in the collection process. Now, merely collecting the products is not enough. And you have to basically identify what can be remanufactured and what cannot be remanufactured. And then there are legal issues relating to that, because when you segregate the products, there will be certain amount of products or certain parts which will need to be disposed of. So how do you dispose of these products is also a critical aspect, because there are rules governing waste disposal in almost all countries across the world. So merely being in the remanufacturing market does not mean that you can escape waste disposal per se. Not everything can be remanufactured, and you will have to come up with a mechanism to also dispose of what cannot be remanufactured. Plus, there is also the fact that during this process, there has to be transparency in evaluating what can be remanufactured and what cannot be, because there may be some remanufacturers who may choose to basically remanufacture only what is the most valuable and then throw off the other parts which might be environmentally damaging. So this is also a parameter as to whether there has been maximum remanufacture or not, or whether it's only for the most valuable resources. Now, after you have identified what can be remanufactured, now you disassemble the product, and you need to basically understand what parts can be remanufactured, because there's a limitation on what will be available for you. Not all products which can be remanufactured will be remanufactured ultimately, because there will be a limitation on what supply is available to you in terms of spare parts and what you can actually do. Now for OEMs, this is generally simpler, because of course they have access to the original suppliers. For others, it can be a complicated measure. So there are legal issues on whether there should be mandatory supply of parts. Next is reconditioning and replacement of products when needed for completing the remanufacture process. So how we will obtain the products or the spare parts for remanufacture is another legal issue, because sometimes the original suppliers to the OEMs may refuse to give it to a third-party remanufacturer. So do you have any legal path to ensure that third-party remanufacturers get the products if they want to get into remanufacturing? Next is ensuring that no replacement products violate laws, because sometimes what might happen that in the absence of supply from the original spare part manufacturers, you may have to basically look for alternative suppliers. But would you violate patent laws if you look for alternative suppliers to remanufacture the product? And whether these alternative suppliers would be licensed by the original manufacturer? Now, these are important legal issues. And lastly, there was something which was talked about resending the product back into the market, and what are the standards which need to be followed. Now, this is a question which again requires a lot of discussion, because can you evaluate the remanufactured product as per the same standards for new products? New products is a question which needs to be seen. Now, while theoretically it is always possible to say that the remanufactured product will match up to the original standards, but the other part of the question here is whether a third party who is remanufacturing the product, will he be able to guarantee that this will perform at the same standards as the original manufacturer. And since there was a discussion in the morning where it said that warranty is generally provided. So what is the exact scope of this warranty? Is it the same as the OEM, or is it a different type of warranty which is provided, is also an issue. So you see that throughout the remanufacturing process, there are different questions which arise, particularly in terms of legal issues which need to be answered, and most of them can only be answered if there are clear standards for them and clear legislation in place. But ultimately, this is what is lacking, not only in India, but in many countries across the globe. So we have already talked about the definitions in the morning, but something that we need to understand is that remanufacture does not happen in all industries, and this is something which was under focus. So there are certain core areas where it happens, that is capital intensive durable products with relatively longer product life cycles. So examples are aerospace, consumer products, electrical apparatus, IT products, locomotives, machinery, medical devices, vehicle parts, office furniture, restaurant equipment, and retreaded tires. And it would not be much of a surprise to say that almost all of these industries, there have been a lot of litigation between consumers who want the right to repair the products or remanufacture the products, and the original equipment manufacturers who do not want to provide such a right or want to have such exclusive rights. But it is not that discussion has not happened at all. Discussion has not happened at all at the global forum. So in 2008 itself, the World Trade Organization discussed how we can promote remanufactured goods. So there was an idea right in 2008 that we need to promote remanufacturing. So there was a discussion on how this could be promoted, and we'll look into it in the next slide. And this problem has also been identified, the fact that there are issues regarding regulatory standards that has also been identified in developed economies, particularly the European Remanufacturing Network, which works under the aegis of the European Union. They say that regulatory barriers to the sale of remanufactured goods has been identified as a key issue which needs resolution. So the picture is not yet black and white and needs further discussion. Right. So to provide you the complete picture, it's not that there are no standards at all. Globally, in developed economies particularly, there are certain standards which define what is remanufacturing. So of course, there are the British standards which are there in BS, which is based on ISO 88871 and 88872, and they basically talk about remanufacturing and provide a definition of what exactly is remanufacturing. But of course, we'll not look into the details of it. And in the USA, which is probably the market leader here, we have something called the Reman Standard, which has been developed by the Remanufacturing Industries Council. And remanufacturing has also been embedded in the domestic law of the USA. So what has happened is that particularly for locomotives that means railway engines, they have included ideas on how these could be remanufactured. Plus, in terms of environmental protection law, they have included remanufacturing as a specific process which needs to be regulated and which can help in environmental protection. So yes, in the USA and in UK, there have been steps taken to basically codify the definitions to aid the industry. I mentioned about the WTO. So way back in 2008 and in 2009, the WTO members, of which India is also one of the members, and WTO members, most of the global trade happened between the WTO member countries. They also looked at remanufacturing. And they came up with a temporary definition. So it's not the final definition. It is a temporary definition. The document which is published itself says that there's a temporary definition which will go through a relook. So they came up with a three-part definition, which I think is most apt to identify the situation. So they say that remanufactured good means something which is entirely or partially composed of parts that have been obtained from disassembly of used goods and have been processed, cleaned, inspected, or tested to the extent necessary. They are in original working condition and has a warranty. So the global standards have been taken up by the WTO members as well, who feel that this is something which need regulation and promotion, particularly in the current scenario. In India, however, the discussion on remanufacturing has been scattered. So, well, historically, if you go back to 1970s, 1980s itself, there are a lot of cases in Indian courts. But what are these cases related to? These cases are related to taxation of goods. So these cases are always on the debate whether goods should be taxed as remanufactured goods separately, or they should be taxed as repaired goods. So this was something which has been always discussed by the courts since the 1970s at least. But there is no discussion particularly on what exactly would be the standards for remanufacturing. So there is a hodgepodge mix and match type of combination of cases which discuss the processes for particular goods per se, like they discuss for glass, they discuss for certain industrial products such as bearings or machinery, but there is no clarity from a regulatory perspective. And these are all related to taxation as to whether higher taxes should be imposed or whether lower taxes should be imposed. But similar to the timeline of the WTO discussion in 2009, the then Minister of State for Heavy Industries, he mentioned that the industry can expect guidelines for remanufacturing within 6 months. But probably because of the changing political scenario, those guidelines never came out in 2009. The current day discussion in India on remanufacturing is in two aspects. One is the right to repair law. Now, this has been widely covered at least since June and July of this year, that the government is looking forward on a right to repair law, under which new players would be encouraged to come up in the repair market, particularly for electronic goods, and they could get involved in remanufacturing. So that is one part of the discussion. The second part of the discussion is in something called the Draft National Resource Efficiency Policy, which was released in 2019 by the Ministry of Forests and Climate Change. Now, this Draft National Resource Efficiency Policy is a document which is similar to what is seen in many developed countries, where they are planning how we will basically utilize our natural resources to the fullest and how we will reduce dependence on import of critical commodities. So the government realized that critical commodities, particularly those used in national security, defense, and essential industries, need to be regulated. There needs to be a control mechanism for these resources, and they came up with the Draft National Resource Efficiency Policy. Now, in this policy, they have a 6R principle. That is, we will promote basically efficiency in natural resources through reduction, reuse, recycle, refurbishment, redesign, and remanufacture products. So that's probably the clearest idea that the government is thinking about promoting remanufacturing in India. And how are they going to promote remanufacturing? They're saying that we will introduce separate certification steps for remanufactured products. We'll rationalize the tax regime to provide a special tax regime for remanufactured products so that they're tax competitive as compared to new products. Tax holidays could be provided, and the government, because it is the biggest purchaser. So if you look at who are the biggest procurement who involved in the biggest procurement of goods in the market is government and government agencies, which procure a lot of goods. And they're saying that we will also basically promote remanufactured products in the government procurement process, and recycle or remanufacture old products also, which are no longer used by the government department. So yes, in addition to the right to repair law, the government is also looking at remanufacturing from a resource protection or better utilization of resource perspective. Right. Then the next part of the discussion is what is already on the ground, because this right to repair law and the national resource efficiency policy are still on the discussion board. So what is on the ground? So if you ask me, on the ground in India, probably the only legislation which comes closest to regulating remanufacturing is related to e-waste or electronic waste, and that is through the e-waste management rules of 2016. Now, while these e-waste management rules do not specifically define remanufacturing, but what they have created is that they have created certain licenses for entry of new companies who could be involved in a few things like dismantling, refurbishing, and recycling, which could be closely related to remanufacturing. But the limitation here is that it only covers electronic products. It does not cover anything else. So the closest license which you can get probably as a remanufacturer of electronic products in India is a license for refurbishing. So the definition of refurbishing is very wide here. So it covers repairing or extending its work life. So probably if you are going to enter as a remanufacturer for electronic products, this is the license that you need to acquire. And then within the act also there is a separate schedule on what products can actually be refurbished, or dealt with under this law, under the e-waste management rules. Now these implementation of these rules have had an impact in the market. So what has then happened is that they have basically encouraged new players to come into the market for recycling and basically repair of electronic products which have reached the end of their life. And yes, probably it's a developing market, something which is still going on, and which is still under development. Now, one thing which I would like to flag out, probably which we need further discussion, is basically differentiating between someone who is a dismantler and who is a refurbisher. So here there is a separate category has been provided for dismantlers, but they have not been given the power to use the old parts for remanufacturing, and they cannot do anything with the old parts except recycle them. So this is a limitation which might be there. So if you want that your electronic product is remanufactured, probably it will only be remanufactured if it goes to someone who has taken a license as a refurbisher. So if someone has taken a license as a recycler or dismantler, probably it will not be remanufactured. So that is a limitation which is there in the rules at the moment. Okay, now let's come to the hottest thing in the market. What is going on right now globally? So right now globally, including in India, the biggest discussion is something on something called right to repair. So what this right to repair basically involves is it involves a right that people who once purchase an electronic product or rather any type of product, they should have the right to repair it in any way that they want and with any person that they want. So let's say if someone purchases a mobile phone of brand X, it should not be the fact that he has to only go to the authorized service center of brand X to get his product repaired. Instead, he should be able to basically get it repaired by any person who is considered trained enough to do that. The Indian government is looking at it. The Indian government is looking at it to promote the right to repair. But one of the front runners here is the state of New York in USA, which in 2002, June 2022, exactly, sorry, 2022, June 2022, it passed the legislation called the Right to Repair Act, but it has not yet been implemented because the governor has not signed it. There, they tried to create a right to repair for the first time in the USA. And what they tried to do is that they tried to basically provide electronic equipment manufacturers a mechanism to enable this right to repair. So for customers, it meant that they could take it to any trained personnel, and the responsibility on the electronic manufacturers was that they have to provide the parts, tools, service manual to independent service providers so that customers could get their electronic equipment repaired. But this is just a start. This is just a start. Why? Because this right to repair law in the state of New York is very limited. It's limited to digital electronic equipment only, and it's not does not extend to other products. So it's a very limited right, which is there, similar to the right in India, where you have to basically regarding the e-waste rules, which cover electronic products only. The right to repair in New York also involves electronic products only, which I think is the low-hanging fruit. This is something which could be done because everyone uses an electronic product which may be of high value and they would want to get it repaired. The law also does not specifically define remanufacture, but of course, because it has a wide definition of repair and maintenance, so probably remanufacture would also be included in these definitions. But yes, it also does not include a clear definition of remanufacture. But the US is unfortunately not the leader in right to repair. The leader in right to repair is the European Union, where the right to repair is not only present for electronic products, but it's also available for cars. It's also available for furniture products as well. So the EU has regulations and directives in place that manufacturers have to enable easy repair of products, including cars, including electronic fast-moving electronic consumer goods, and of course furniture products as well for few years after the products have been discontinued. So let's say manufactured a washing machine for 5 years and it was there in the market for 5 years. So from the date it was discontinued, spare parts for the machine have to be available for the next 10 years. So it would ensure that the machine would at least have a lifetime of 10 years at the very least, during which the customer would be able to repair the product. So the European Union is the leader in the right to repair, but they have not specifically called it right to repair. Instead, they have put forward a patchwork of indirect legislation, which has created this right to repair. And this has been very effective till date. It has been very effective till date and has been widely appreciated. Now, even with all these situations, there is of course the legal issue of patents. And as all scientists should know, patenting is probably considered one of the benchmarks of achievement. So there is always a tussle between the patent holders, who are frequently the original equipment manufacturers, and the remanufacturers on the market. So the controversy is on the right of the customer to seek a remanufacture of a patented product, and the right of third parties to, of course, recreate the patented product. Now, in common law countries like India, USA, United Kingdom, we have a principle called the doctrine of exhaustion. And in simple word, it means that once you sell a product to someone, there is nothing that you can do on that product. The rights which you had under the patent always get extinguished. That means the rights which you had as a patent holder, they get extinguished the moment you legally sell a product to someone. Now, this of course is a controversial issue, because what happens is that manufacturers of many products such as let's say manufacturer of a printer, may not always want that his printing cartridges are refilled. So what they tried to do, what these manufacturers tried to do, is that they tried to basically protect their patents by including conditions of the sale. And what these conditions of the sale said, that if you basically purchase our product, you have to basically refurbish or refill the cartridges at our office only, or at our dealers only. This of course existed for some time. The US court supported this doctrine for some time, and they received a huge boost in a case called Quanta Computers in 2008. So in Quanta Computers, uh, they basically had an idea. They had an idea that uh, they would basically not be able to protect this exhaustion doctrine. So yes, there was the doctrine of exhaustion in 1992. There was a case called Malincroft, where what happened was the court said that we will limit this doctrine of exhaustion. We will not allow the purchasers of the products to freely remanufacture and refurbish their products. But in 2008, we received the first big boost when we had Quanta Computers, where the court said that, okay, fine, the doctrine of exhaustion has a broad perspective. So yes, you can basically repair any products that you have purchased. Now, in 2016, the remanufacturing industry received the biggest boost in the US in a case called Lexmark International. So Lexmark, as many of you know, is a printer manufacturer, and they tried to basically protect the right for remanufacture of the cartridges. And the US Supreme Court in this case upheld the exhaustion doctrine and said that you cannot basically exclude people from remanufacturing the products, because that would mean creation of a market monopoly. So this principle was then followed also in a case in 2020 in Australia called Psycho Epson. Again, case related to printer cartridges, where they said that you cannot limit people to get their cartridges refilled or remanufactured at a particular company only. In India, of course, the picture is not yet very clear. What happens? So, but still it is expected that as a common law country, we will follow this exhaustion doctrine, and there is of course a right of remanufacture of the products. But there are still questions remain as to what is the extent of this doctrine of exhaustion. Does it mean that once you sell the product to a person, you have given him a right to remanufacture it in India, outside India, across the globe, within SAARC? What is the exact extent of this doctrine? Of course, these questions remain, but probably they will come up in the courts in some time. Right. Moving on, we come to the burning question, that is OEMs and remanufacturing. So since the morning, we have heard about OEMs and their interest in remanufacturing, and I think this is probably something which is of interest to everyone, that whether only OEMs should have a right to remanufacture products. Generally, the remanufacturing industry have fought it in the courts, particularly in the European Union. So we have the famous case of Canon in 2014, where what the Toner and Inkjet Remanufacture Association did is that they tried to prevent Canon from taking patents over the remanufacture process. So Canon, what it tried to do was it tried to basically patent certain remanufacturing processes itself, and the industry fought back. And they were successful. But of course, as you know, that this will not be the end of the fight between both the parties. I use the word fight, which is not politically correct probably. So I will probably reframe it and say that end of the tussle between both the parties. So what the OEM industry has done is that OEM industry has taken it as a multi-pronged fight. So what they have tried to do is that first they have tried to basically ensure that the spare parts which are required for remanufacturing may not be easily available to the remanufacturers. And this is something which is of course controversial, which right to repair laws have tried to remedy by ensuring that everyone gets the spare parts. But OEMs, what they try to do in many situations is that they try to limit the supply of these spare parts. The second thing is that they are going for planned obsolescence. Now, what planned obsolescence, what happens is that the OEMs say that will not provide support for a product after a given time, and spare parts will also not be available. So this means that if the spare parts are not available, sometimes remanufacture may not be possible and third-party remanufacturers may be hurt. Some OEMs, however, have taken a different approach. What they have said is that we will fight with third-party remanufacturers on the ground. So what they have done is that they have come with their own remanufacturing programs. One example is Canon. Canon has dedicated plants dedicated to remanufacturing, which is, I think, a good approach. There is more competition in the market. And what they have also tried to do is that they have tried to reduce the amount of products which could be remanufactured per se. So what they have tried to do is that they have tried to include consumables within the products which may not be remanufactured easily, so they have tried to make the process complicated for remanufacturers, and whatever is the consumable also is then patented. So remanufacturing, it might mean a violation of patent law. So this is one approach they have taken. But courts have tried to step in. They said that sometimes you may need to issue mandatory license of products, particularly if there's a requirement to provide competition in the market. But I think there is a more easy way out here, which can be an option to reduce the tussle between OEMs and third-party manufacturers, and that is that there could be an exclusivity period for, let's say, 1 year or 2 years after the sale of a product, during which repair could be taken only by the OEM because they provide the warranty, and later customers may approach for remanufacture with third parties. Of course, this may not be acceptable to all parties, but this is one of the ways. But probably there could be better ways which come up after discussion. And lastly, there is of course the issue of how these third-party remanufactured products will be used, because we have something in the industry which is called end user license. An end user license means that the final user of the product, he basically says that I will not send this product to any countries which are covered by sanctions of the United States or European Union or UK or the United Nations, and these products will not be basically sent to these countries because they may be misused in violation of the law. But what happens in case of remanufactured products? Will these remanufactured products be diverted to such countries, or will this be a violation of the end user license? Is a question which still needs to be answered, which still needs to be debated. And of course, this needs greater clarity on how you would prevent a diversion of such products to prohibited markets. Right. Moving towards the end of it, I had mentioned before that there is the Basel Convention on Transpoundary Waste Management. Now, Basel Convention on Transboundary Waste Management specifically prohibits cross-border trade in hazardous waste. And there is no special exemption which has been provided for products which are going to be remanufactured in another country. So let's say if laptops are collected in India and they have to be exported to Singapore for remanufacturing, that would be a very long and complicated process. That would be a very long and complicated process. So to understand this question of what exactly can be exported, cannot be exported, would be a tough ask and would require multiple licenses. And that also has happened because remanufacturing is not defined in the convention. So probably the only exemption that you find in the Basel Convention where you would not require licenses and permits is for something called reuse, where you can repair, refurbish, or upgrade electrical and electronic assemblies. So that is probably the only product which can be transported across borders without licensing and permits for remanufacture. For everything else, you'd require licenses if you basically collect the product in one country and want to remanufacture it in another country, or otherwise it might be covered by the Basel Convention. So finally, where are we now? We are now in a stage where a lot of issues need resolution. First is, if we do not have industry standards for remanufacturing, particularly like in India, we may need to come up with voluntary standards framed by the industry itself for self-regulation. There's a need to basically identify the compliances which may be needed for remanufactures. And you would also need to understand how you would brand and sell remanufactured products. So let's say someone buys an old electronic product and it is remanufactured. Will it be sold under the old brand name, or will it be sold under a new brand name? Or will this product, if you sell it under a new brand name, would it be legal? These are questions which still need to be answered. This particularly happens in case it's a third-party remanufactured product. Next is, there needs to be policies for importing products for remanufacturing and also to export the remanufactured products, because otherwise it might be in violation of international laws. We might need separate certification standards for remanufactured products. And of course, these standards need to be framed in basically in discussion with the original equipment manufacturers, because they might feel that if a customer is using a remanufactured product and it does not perform to the original standards, their own brand equity might get damaged. So that is the idea they might have. So we have to seek greater clarity on that. And lastly, there is an issue of quality assurance, as to how do you ensure quality assurance for remanufactured products and how they would be covered under consumer protection law. So customer service is an area which still needs a lot of discussion as to how you can basically make it compatible between the interests of the OEMs and third-party manufacturers, and so that it does not hurt the interests of the customers who go ahead and purchase a remanufactured product basically created by a third party. So these are different issues which of course need discussion. Probably will not have solved everything. I have probably left you with more questions than answers, but thank you for providing me the opportunity. And of course, yes, back to our presenter. Thank you.
Thank you. Thank you, sir. So there are, I think, many questions for you. Like,
Yeah.
Can you read the questions? Or
yes, I am able to read the questions. I will probably start with Mr. Kumar, who has asked, can repair may also be termed as remanufacturing, or repair along with some replacement of some items by new products can be termed as remanufacturing. So Mr. Kumar, here this discussion on whether repair is remanufacturing is a stopgap arrangement. It's a stopgap arrangement till the time you come up with a clear definition of remanufacturing in the laws. You will have to probably use that as an extension, use as an extension to run your business or to be legally compatible. But whether repair and remanufacture can be used interchangeably, it's not true. Probably remanufacturing can be one of the angles of repair in case a definition is not clearly available under the law, but those words cannot be basically interchanged. Next is how remanufacturing will be cost effective, particularly in automotive sector, if we consider the development of EV in recent years. Now, talking about electronic vehicles, remanufacture of electronic vehicles is probably an industry which will grow. We of course have the e-waste management rules in place, so at least some parts of an electronic car an electrical car could probably be reused. So if you talk about EVs, probably some parts of them can be reused and remanufactured under the current rules, but we do not have a framework in place yet. But yes, if a framework is brought about for remanufacturing them, it will be highly useful. I think because they have lithium-ion batteries as one of the key components that is particularly critical. And of course, an EV uses things such as motors, which probably could be remanufactured. So if there's a framework in place, it could be very, very useful. Mr. Ankit Kumar asked to start up a remanufacturing industry. What are the challenges in national and state business laws? So Mr. Kumar, I think probably the biggest challenge you would find is under waste management laws, because we do not have waste management law clearly in place except for electronic waste. So for electronic waste, if you're establishing a remanufacturing plant, particularly under the head refurbisher, then it is definitely possible. For other industries, you would have to basically open it as a normal factory or industry and then try to be legally compatible. But yes, for other industries, there are no set standards. So if you are involved in the electronic waste industry, I think there is a framework in place. For other industries, it's still a work in progress. And lastly, what do you mean by pacific means and coercive means? So pacific means basically means measures such as mediation, conciliation. These are considered as pacific means. Coercive means basically means where two parties are pitted against each other. So going through means such as use of force or a threat, or probably sometimes again aggressive judicial procedures could be considered as coercive means. And how should an Indian manufacturer approach setting an international business dispute? I think most of the business disputes globally are now settled under the New York Convention through arbitration. So arbitration is probably the most effective way nowadays for international business dispute resolution. So that's the common standard. Okay, right. So those are the questions that I can see.
So there are a couple of hands are also raised. If you allow me, then I can.
Yes, please go ahead.
Yeah, I'll, there is Mr. Rajnikant. So yeah, Rajnikant, please.
Good afternoon, sir.
Good afternoon.
Actually, there is always a tussle between in case of vehicles. Canon has applied one policy for remanufacturing, but in case of vehicles, there is always a tussle between date of sale and manufacturing date. Vehicle is covered with on the basis of date of sale, and the component parts are covered on the basis of manufacturing date, like tires, battery, and pumps, and etc. And there is another tussle for refurbishment business, that there is a tussle between warranty policy and insurance policy, and the new policy of remanufacturing, how it will get placed between these all. Canon is maybe the total manufacturer of all the components, but in a vehicle industry, components are assembled, and there are a lot of different policies for vehicle, for component. There is insurance policy, then warranty policy. Then how this will fit in case of vehicles, remanufacturing policy, it will be a challenge, I think.
True, Mr. Kant. But in the vehicle industry, in the automotive industry, we already have a good position, particularly in terms of the more valuable components such as engines per se. So almost all major engine manufacturers, including Tata, Cummins, they have remanufacturing policies in place. Entry of a third party remanufacturer, that is something which I think will involve tussle. But yes, you are absolutely right. More clarity on policies is still required. Sir, you are on mute. You're on mute, sir. Sorry.
Okay, sir. Thank you. So there is one more speaker, Arjun, Mr. Arjun Agrawal. Mr. Arjun Agrawal, do you want to ask anything?
Yes, sir.
Yeah.
Hello.
Yes, Mr. Agrawal.
Yeah, good afternoon, sir.
Yes, good afternoon.
Sir, I wanted to ask whether a right to repair act like the one in US would be more effective than the one in European Union, because European Union has a bunch of different laws, as you just said today, and they are harder to implement, but they also allow less room for wriggle room for loopholes. So is a single all-encompassing law like the right to repair of New York legislation better than the one in European Union, or Is it like more nuanced than just one is better than the other?
It is more nuanced than one is better than the other. Why? Because the New York law is basically a state legislation. It's not a federal legislation in the US. So it will be only applicable in the state of New York. The European Union, on the other hand, it brings about two types of laws basically. One is called directives and second are called regulations. So directives, they are basically brought about by the European Commission and every member state. So all the member states of the European Union, they have to implement it by making their own law. And regulations are implemented directly. Now, when you make directives like the European Commission has done, what they have done is they have basically set the groundwork. And it is more useful, particularly in terms of the applicability. So it's all European Union countries, so it's much more wider. And these directives were not brought about saying that these are under a right to repair. Instead, they were brought about to extend the life of products. Now, indirectly, they became a right to repair, but the original intention was that the product should be used for longer duration. Now, something like the New York law, if it comes, it's very, very good, but there will always be a tussle with the industry. You see, the law is very, very limited. It's only limited to electronic goods and certain kinds of electronic goods. So,
yes, so like computers and mobile phones.
Mobile phones. The European Union rules, regulations and directives, their scope is much wider. They cover things such as washing machines, they cover electronic devices, they cover furniture as well, they cover cars. So I think there is no, you cannot, they are both basically apples and oranges. You cannot compare both of them, but they are both approaches to getting the goal together. The European Union approach is older and it covers more countries. So probably the applicability is greater, but we still have to see how the right to repair works out in the US because it's still an experiment. It is not yet been signed. It has not yet come into force. But in EU, we know that it works. So at least there is some evidence that it works, which is helpful. Right.
All right. Thank you, sir.
Thank you. Yeah.
Thank you. One more. I'll just take one more. So, yeah. So this is Smriti Pradhan. Smriti Pradhan. So do you want to ask anything? Any question? Okay. So then I think I know my hand. So with this, sir, I'd like to end this session. Thank you, sir, and it's my privilege to present the vote of thanks on behalf of our both the organization NIMT and FMFI, and we would like to express our gratitude to you, sir, for sparing your precious time with us, and thank you, Dr. Anshumar, for sharing this enlightening presentation with all our attendees. And you have covered, you rightly said before starting the session, like these are the field generally people not discuss, and this is very, very well needed actually, in terms of understanding like the business laws in remanufacturing, like right to repair law and others, and what are the standards available for the remanufacturing perspective, which is a kind of a new domain for many of the participants. And Dr. Mansuman has also briefed in detail about the legal aspects, which are the issues in different steps of remanufacturing process, like collecting the return, segregation of the item, disassembly, conditioning, licensing, warranty. So I'm sure this information will be very useful for all the participants and the young. I see like people are very interested in getting more information about how the startups can get the opportunity from this field. So we really look forward for more active participation from all the participants in the upcoming sessions also. So thank you, sir. And before moving towards the end of this session, I'll like to announce okay, the next session will start at 3 p.m. So there again, the session will be on the circularity in remanufacturing, where we have 4 speakers. So the session will start at 3 p.m. and it will end till 6 p.m. And with this word, I will announce the end of this session on remanufacturing for sustainability. With thanks to all the panelists who are present in today's session, I would like to extend a sincere and our sincere thanks to our Honorable Director, Professor P.P. Chattopadhyay sir, also for his vision and commitment to work this execution of this event, and to bringing out this relatively new domain for all of us. So thank you, sir. Thank you once again, sir. So, yeah, look forward to stay connected, sir. Thank you.
Thank you.
I'll just end today's session.